So in the last video, we talked about the alternating series test, and one of the reasons that the alternating form of a series will sometimes converge when the absolute value of the series will diverges should be fairly intuitive. But if it's not, here's a graph that we can a graphical representation of what is going on in this alternating series. So let us pretend that this is our number line, and this line is just to show different numbers. Let's pretend that this is the sum of n, and that this is our sums lie on this number line. And so when we have the first term, if we go back to our alternating harmonic series, when we have the first term, we have 1 over 1. So let's call this point 0 then. Start from 0 here. And then let's call this distance -1. So we go backwards this way. And we know that this is A1. And we know that from here to here we have S1. And then we know A2 is 1/2, so it's half of this. Should go to -1/2. Of 1 plus 1/2 becomes -1/2. And this is A2. We know that this is S2. And then we know that A3 is less than A2, but it's also going in the other direction. So -1/2 minus 1/3 is whatever it is. It must be somewhere here. And this is S3. And then this is S4. And this is S5. It should be very, very intuitive at this point that because my arrows are going are getting shorter and shorter, and I'm alternatingly going in the opposite direction, I eventually reach a point of convergence from what it looks like somewhere here. So this we can call S infinity, because this is a sum as n goes to infinity. Exactly what this number is, but by what we know as the alternating series estimation theorem, we can actually find the upper bound of what our error is if we try to approximate this sum to infinity.